Hello everyone, we're on question 9 now of paper 2 from 2023 for Edexcel. Now we've got, what have we got here? A parametrics question. So parametrics can be a bit tricky sometimes, and I think this part A, I wouldn't say it's horrendous, but it's definitely middle of the road, probably like sort of about grade A, something like that. So it says the curve C has parametric equations x is equal to t squared add 6t minus 16 and y is equal to 6 ln t add 3, where t is greater than minus 3. Show that a Cartesian equation for C is y equals a ln x add b, where x is greater than minus b, where a and b are integers to be found, 3 marks. So we basically have got a number of options. We need to find some way of eliminating the parameter. We need to kind of get rid of the parameter. So looking at that x equation, the t squared add 6t minus 16, it's not immediately obvious that that kind of like factorizes in order to give us any nice values for t that we could then sub in. So that's a bit of an issue. So it's not very straightforward from that point of view. So I'd say we've got two approaches. We need to find some way of representing that x equation that would allow us to kind of sub the something in to get a Cartesian, or we could rearrange y to make t the subject, okay, and sub that in to get the Cartesian. So those are our two options. Now I'm going to go through both options. The first one involves completing the square. Now this option, I must admit, I don't think it's the most obvious thing in the world. And I'm not sure whether it would have occurred to me in an exam if I was confronted with it. But here's how it works. So the link, I guess the link for recognizing that completing the square is the appropriate thing, is that here, notice we've got t add 3 in the question, but we've got t squared add 6. So when you complete the square on this, it's going to give you something with t add 3 in, which would be super useful because you could then sub that in. Okay, so I guess that's the link, and I don't think it's a very obvious link. Okay, a little bit tricky to spot that. But here's what we would do. So if we were going to do the completing the square approach, it would unfold as follows. I'm going to complete the square on this expression. So I'm going to write t add 3 all squared, take away 3 squared, is going to be minus 9 minus 16 is minus 25. So x is equal to t add 3 all squared minus 25. So I then add my 25 across to the other side and square root. So I get an expression now for t add 3 is the root of x add 25. Now with this particular approach, that's really nice because I can directly replace t add 3 with root x add 25. Okay, so we now have y is equal to 6 ln of root x add 25. So using the laws for logarithms, I rewrite root as to the power of a half, and I take that power of a half and put it at the front there using the power law of logs. So I get my expression is my Cartesian equation is y is equal to 3 ln x add 25. And remember, Cartesian means just in terms of x and y. So that's one approach. Tricky in the sense that it involves spotting that completing the square enables you to rearrange your x into a format where it can be subbed directly in. So what's the other approach? Now, I think if I was in the exam, I would have got maybe a bit confused, and I don't know if I would have spotted that in the exam. So I might have tried to do the other method, which is to try and make t the subject of y. So let's have a look at that one, see how that unfolds. So I would divide by 6 if I was doing this alternative method. So given me y over 6 is ln of t add 3, I'd reverse the logs. So I've got e to the y over 6 is equal to t add 3, and then I would subtract 3. Okay, so I get e to the y over 6 minus 3 is equal to t. Sub that in now to my x equation, and I get x is equal to e to the y over 6 minus 3 all squared, add 6 e to the y over 6 minus 3 minus 16. So I've got to expand this double bracket. So it's going to go e to the y over 6 times by e to the y over 6, which is e to the y over 6 add e to the y over 6, which is e to the y over 3. I would get a minus 3 times e to the y over 6. I would get another minus 3 times e to the y over 6, which would give me minus 6 lots of e to the y over 6. And then finally, my last term would be minus 3 times minus 3 is plus 9. Okay, so that's these three terms here are just expanding that double bracket. Okay, and then multiplying out this bracket, I get 6 e to the y over 6 and minus 18. Okay, now what's nice here, and this is rather fortuitous that this has happened, those cancel. Minus 6 e to the y over 6 and plus 6 e to the y over 6. They cancel out. And when I collect like terms with my plus 9, minus 18, minus 16, that comes to minus 25. So it does actually drop out quite nicely now, because all I need to do now is add 25 across to the other side, take natural log and times by 3. And you can see that I've derived the same result as I did through the other method. So those are your two approaches for part A. Definitely, yeah, I think quite tricky, to be fair. Part B looks pretty standard. What's going on here? The curve C cuts the y-axis at the point P. Show that the equation of the tangent to the curve C at P can be written in that form. So in order to find the equation of a tangent, we need two things. We need a gradient and we need a point. So in order to get our gradient, we're going to differentiate our y equation. So if y is equal to 3 ln x add 25, dy by dx is going to be 3 times by 1 over x add 25. And technically we need to think about the chain rule, but the derivative of the inner function is just 1. So now the point P is on the y-axis, which means that the x value is going to equal 0. Okay, so our x value is equal to 0 because we're at the y-axis, which means the gradient of the tangent is 3 over 25, because we've got 3 over 0 add 25. Okay, so we found the gradient of the tangent. Now we could do with knowing the coordinate of P. Well, we know that the x-coordinate of P is 0 because it's on the y-axis. So we now need just to find the corresponding y-coordinate. And we're going to do that by subbing in x equals 0 into our y equation. So when x is 0, we get y is equal to 3 ln 25. So that's our y-coordinate. So we've now got the full coordinate of the point P. So we have everything we need now in order to find the equation of the tangent. So we're going to use y minus y1 is equal to mx minus x1. So y minus 3 ln 25 is the gradient that we found before, the 3 over 25, times by x minus 0, because 0 is the x coordinate. I'm going to add that 3 ln 25 over to that other side. There we go. So that is good. It says that they should be integers, a, b, and c, so I need to get rid of my fractions. So I'm going to times everything by 25, giving me 25y equals 3x plus 75 ln 25. The next thing I need to notice is that I've got 25 here, but the question says it should just be ln 5. So I'm going to rewrite 25 as 5 squared, use the power law and bring that 2 to the front. 2 times 75 is 150. So I've now got 25y is equal to 3x plus 150 ln 5. Now we want to get this whole thing in the required form that they're after. ax plus by is equal to c ln 5. Okay, so what I need to do now is, let's have a look. I'm going to add the 25 over to there. Okay, so that's going to become 3x minus 25. And then I need to move that 150 over to the left-hand side. So therefore, bringing the 25y over to the right-hand side gives me 3x minus 25y. And then I've got to take that across to the left-hand side, giving me minus 150 ln 5. Okay, and I think in the answers, they've just written it the other way around. They've just written it as 25y minus 3x is equal to 150 ln 5. But either one of those versions would be absolutely fine. Perfect. I hope you found that helpful, and I'll see you in the next video.